Hello. Today I will teach you how to construct a truth table for a proposition. First of all, we need to know why do truth tables for propositions, why learn them. Then I will show you how to do a truth table for a single proposition. Finally, I will show you how to do a truth table for two or more propositions. Remember, a proposition is simply a statement. And a statement is a sentence that is either true or false. And also remember, arguments are made up of statements. Okay, so why learn truth tables for propositions? Well, we need to learn this in order to learn how to do truth tables for arguments. And why learn truth tables for arguments? Because we're trying to learn a method for showing whether a given deductive argument is valid or invalid. Alright, so first I'll list the steps for filling out a truth table for a proposition, and then I'll give you an example. So the first step is to fill out the top left and top right columns of the truth table. The second step is to calculate the number of lines needed for the truth table, and this would be on the bottom left column. The third step is to fill out each column in the left bottom column of the table. 4 is to identify the order of operations, which operator column to fill in first, which to fill in second, which to fill in third. And here's how you determine the order of operations, according to the main operator. So the operator with the smallest range should be filled in first. The operator with the next smallest range should be filled in next. And you should continue in this manner until you get to the operator with the largest range, namely the main operator. This one should be filled in last. Then apply your knowledge of the 5 operators, namely the definitions, the truth table definitions for the 5 operators, to fill in the truth values according to the order of operations. 6, box the main operator column. This column tells you the truth value of the statement for every possible assignment of truth values to statement letters. Okay, let's do this step by step for the following proposition. P or Q and R. So first step, fill out the top left and top right columns of the table. How do you do that? In the top right, you put in the statement that you're analyzing. So P or Q and R, just right here. That's the statement we're trying to do a truth table for. And then on the top left column, you list the component statements. Each component statement. So in here we have P, Q, and R. And we list them over here in the order in which they appear from left to right in this statement. So P occurs first, we put that here. Q occurs second, we put that here. R occurs third, we put that here. So we filled out the top left and top right columns of the truth table. Second, calculate the number of lines needed for the truth table. So the number of lines meaning down here on the bottom left, how many lines of T's and F's do you need to fill out? To figure out how many combinations there are for a given compound statement, you need to calculate 2 to the power of the number of component statements. So for this compound statement, P or Q and R, to know how many lines go down here, you calculate 2 to the power of the number of component statements in here. Since we know there are 3 component statements, P, Q, R, we do 2 to the power of 3. 2 to the power of 3 means 2 times 2 times 2, and that equals 8. So we need 8 lines of T's and F's. And the reason we're doing the 8 lines of T's and F's is because we want to list every single possible combination of truth values for P, Q, and R. You know, you can have T, T, T when P is true, Q is true, R is true. You can have F, F, F when P is false, Q is false, and R is false. And you have to list every single combination. So there are actually 8 combinations, and we'll see that on the next slide. So what you do to fill out those 8 lines is you fill out each column in the left bottom or the bottom left column of the table. For the column closest to the middle line, R is the column closest to the middle line, then Q, then P. For R, you start with T on that first line and alternate T's and F's by 1s. Okay? So you start with T and alternate T's and F's by 1s until you fill out 8 lines. T, F, T, F, T, F, T, F. For Q, you start with, the reason we're doing this is to give all the possible combinations, and this is just a formula for getting all the possible combinations. For Q, you start with T and alternate T's and F's by 2. T, T, F, F, T, T, F, F. And remember, there are 8 combinations, so we do 8 lines. For the last column, we start with T and alternate T's and F's by 4s. So T, 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 F, 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 F. Let's see that filled out on the next slide. Alright, so you fill out the bottom left column of the table. This gives us every single possible combination of truth values for PQR. TTT, TTF, TFT, TFF, FTT, FTF, FFT, FFF. And we did that by alternating by 1s, starting with T here, T, F, T, F, T, F, T, F. Alternating by 2s, starting with T here, T, T, F, F, T, T, F, F. And alternating by 4s, starting with T here, T, 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 F, 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 F. And you need to fill it out in exactly that way. That is our convention for this class, and if you don't, when it comes to the test, you're going to lose points. Okay, what's next for our truth table? You identify the order of operations, which operator column to fill in first, second, and third. Okay, so you have to identify the order in which you fill out this operation and this operation, the logical operators. Here's how you determine the order of operation. The operator with the smallest range should be filled in first. Which has the smallest range, wedge or dot? It's dot. So the wedge only covers the smallest range is the wedge. The wedge only covers the P and the Q, and the dot covers the entire statement. It has in its range the entire statement. So this operator with the smallest range is the wedge, so we fill in that column first. The operator with the next smallest range is the dot, so we fill in that column second. If we had more operators, we would just keep going until we got to the main operator for the statement. Now, there's a reason that the order of operations matters. So in order to determine the truth value for this, you're first going to need to know the truth value for that, as we'll see. So what you do to finish filling out the truth table is you apply your knowledge of the 5 operators, the truth table definitions for tilde, dot, wedge, horseshoe, triple bar, to fill in the truth values according to the order of operations. Okay, so we start with the smallest, the operator with the smallest range first, and we fill this out. And then we move on to the dot, and we fill that out. We'll do that on the next slide. So how do we fill this one out? Well, we need to know the truth for each line. We need to know the truth value for the wedge, given the truth value of P, and given the truth value of Q. Okay, so we look over here. For line 1, P is true and Q is true. For line 1, P is true and Q is true. And when you look at the truth table for the wedge, you see that whenever one disjunct is true and the other disjunct is true, the whole thing comes out true. That's why we put true here. So then we figure out the truth value for the second line. P is true and Q is true. Whenever one disjunct is true and the other disjunct is true, the whole thing comes out true. Then we move on to the third line. P is true and Q is false. With the wedge, whenever at least one of the disjuncts is true, the whole thing comes out true. So that's why for this third line, the wedge comes out true, because P is true. P is a disjunct in this disjunction. Whenever one disjunct is true, the whole thing comes out true. How about line 4? Again, we have P is true, Q is false. With the wedge, whenever one disjunct is true and the other is false, so whenever at least one of them is true, the whole thing comes out true. How about the fifth line? P is false and Q is true. P is false and Q is true. Okay, with the disjunct, whenever at least one of the disjuncts is true, the whole thing comes out true. Same with this one, false, true. Comes out true. Now, the only time the disjunction ever comes out false is when both disjuncts are false. And that's what we have for lines 7 and 8. False P, false Q. False P, false Q. That means that these come out false. Okay, so that's how we filled out that column for the wedge. We've seen all the possible truth values for P, wedge, Q. And we know how to fill out the truth values for those by looking at the truth table definitions for each of our logical operators. For this case, we just looked at the truth table definition for the wedge. Okay, we still need to finish up step 5, by filling out the truth the truth values for the dot. Okay, now how did we do this? Well, for this dot, we have one conjunct, which is P wedge Q. That's the left conjunct. And we have another conjunct, which is R. So we look at the truth value on each line. We look at the truth value for the left conjunct and the truth value for the right conjunct, and we determine the truth value for the entire conjunction based on the truth table definition for the dot. Okay, so on the first line, we have the left conjunct as true and the right conjunct as true. Whenever in a conjunction, whenever both conjuncts are true, the whole thing comes out true. For the second line, we have a left conjunct is true and a right conjunct is false. That makes the whole thing false, because if you look at the truth table definition for the conjunction, whenever one of the conjuncts is false, the whole thing comes out false. For a conjunction, the only time it ever comes out true is when both conjuncts are true. So that's what we have for the third line. Left conjunct is true, right conjunct is true. That gives us true. For the fourth line, we have left conjunct is true, right conjunct is false. That gives us false. For the fifth line, we have left conjunct is true, right conjunct is true. That means that we have a true conjunction. For the sixth line, we have left conjunct is true, right conjunct is false. Whenever one conjunct is false, the whole thing comes out false. So this dot statement is false. And remember, the dot statement is this entire thing. It's the main operator. Sixth line, whenever the left conjunct is false and the right is true, the whole thing comes out false. And eighth line, whenever the left conjunct is false and the right conjunct is false, the whole thing comes out false. So with the conjunction, the only time it ever comes out true is when the left conjunct is true and the right conjunct is true. It's an and statement, right? John and Rita are going to the party. When does that come out true? When they both go to the party. It comes out false every other time. Okay, so we're almost done filling out the truth table for this proposition. We just need to box the main operator column. This column tells you the truth value of the statement for every possible assignment of truth values to statement letters. So, it tells you the truth value of the statement right here, the truth value of the statement for every possible assignment of truth values to statement letters. So when you have P is true, Q is true, R is true, the whole statement comes out true, this whole statement. Whenever you have P is true, Q is true, R is false, this whole statement comes out false. Whenever you have P is true, Q is false, T is true, the whole statement comes out true. Whenever you have P is true, Q is false, R is false, the whole statement comes out false, and so on. So now you know the truth value of the statement on each line, given every possible truth value assignment of, every possible assignment of truth values to statement letters. That's how you do truth tables for single propositions. This was our single proposition, P or Q dot R, and we did a truth table for it, and we found this result. Now we need to do truth tables for two or more propositions. Okay, here's how you set up truth tables for multiple statements. You set up the truth table as usual, you add a table cell, here's our added table cell, here's the usual, right? The cross, right? We've got the cross with the component statements here, and then we've got the single statement here. We saw that back here. We got the component statements, the single statement. So for multiple statements, you just add a cell. If there were 3 statements, you'd add another cell. 4 statements, add another cell, okay? And then you follow the steps 1 through 6 for filling out the truth table for a proposition. So let's do this step by step for the following propositions. We have 2 propositions, P or Q and P dot Q. This is one, this is another. This is just a line separating the two of them. Okay, so we set up the table as usual and add a cell, okay? So that means we have the cross plus another cell. Okay, so then you follow the 6 steps. You fill out the top left and top right columns of the truth table. Remember, on the very top left, you put the component statements. So the only statements that appear in these 2 statements are P and Q. Those are the only simple statements that appear. So we list them from left to right in the order in which they appear across these statements. So P, Q is the order, P, Q. All right. And then here in this first, the next column over from the component statements, we put the first proposition, and then in the next column over from that, we put the second proposition. Step 2, calculate the number of lines needed for the truth table. To figure out how many combinations there are for a given compound statement, calculate 2 to the power of the number of component statements. So, this is a typo. It should say 2 to the 2, which equals 4. Okay? 2 to the 2, which equals 4. Because we have 2 component statements. 1, 2. 1, 2. So you do 2 to the 2. 2 times 2 is 4. So that's how many lines we're going to need down here. Now we need to fill out each column in the bottom left column of the table. All right, and we saw that we pick the line closest to this middle line, separating the component statements from the first statement we're analyzing. And we alternate, starting with T, we alternate T's and F's by 1. Where is it? T, F, T, F. Remember, there are 2 component statements. We did 2 to the second power because there are 2 component statements. That's 4. That's how many lines we need in order to get all the possible combinations of truth value assignments to the statement letters. So there are 4 combinations, TT, TF, FT, FF. And we alternated by 1s here, starting with T, T, F, T, F. And for the next column, start with T and alternate T's and F's by 2's. T, T, F, F. That's how we fill out this one. We don't need the 8 lines because there are only 2 component statements, which gives us 4 possibilities for the assignment of truth values to these simple statements. What do we do next? We identify the order of operations for the statements. So we identify the order of operations for this one and then the order of operations for this one. Well, what's the main operator for P wedge Q? There's only one operator, wedge. So that would be the main operator. It's really easy to identify the order of operations here. Same with P dot Q. There's only one operator, so that's the main operator. So we just fill in this column and this column. And they're independent from each other. You don't need to do wedge first and then the dot. You can do them they're independent of each other. You just fill out the statements independently, and it doesn't matter for the logic of the whole deal. Okay, so first, for step 5, you apply your knowledge of the 5 operators to fill in the truth values according to the order of operations. Okay, so here for P wedge Q, you have to figure out what the truth values are here. Whenever you have the left disjunct being true and the right disjunct being true, the whole statement comes out true. Just look at your truth table definition for the wedge operator, and it'll tell you that. Whenever the left disjunct is true and the right disjunct is false, you get true. The whole statement comes out true. So that's the nature of the wedge. Whenever the left disjunct is false and the right disjunct is true, the whole thing comes out true. Because remember, the only time for a disjunction that the disjunction comes out false is when the left disjunct is false and the right disjunct is false. That's what you have here. False, false, so the whole thing comes out false. Now we need to fill in this column. For the dot, the only time that the dot comes out true is when both conjuncts are true. And that's what we have for that first line. P is true, Q is true, so the whole thing comes out true. For the second line, when P is true and Q is false, the whole thing comes out false. For the third line, when P is false and Q is true, the whole thing comes out false. And for the fourth line, when P is false and Q is false, the whole thing comes out false. Okay. Now you have to box the main operator column. Well, since there's only one operator for each statement, you just box this operator, that's the main operator for that statement. Box this main operator, that's the main operator for that statement, and you're done. That's how you do truth tables for 2 or more propositions. And this is really important to know because, when you come up to an argument, you have, say, 3 propositions, 2 premises, and a conclusion. And you're going to need to know how to do the truth table for those 3 propositions in order to determine whether the argument's valid or invalid. And we'll get to that next lecture.